We will now look at polynomial functions and their graphs by using the factoring method. So before we move to the factoring method, we are going to talk about the end behavior of graphs. So we are going to look at the leading coefficient. That's the coefficient that is the leading term. So the one with the highest degree. So what we're going to do is look at leading term, the term with the highest degree. 2. The exponent will tell the end behavior. So, for instance, if the exponent is odd, then we will have opposite directions. So one direction will go, one end will go up, the other one will go down. If it is even, if the exponent is even, they go the same direction. And then we're going to look at the sign in front of the coefficient. So the sign of the coefficient, if we have a positive term, then the right side goes up. If we have a negative, then the right goes down. Okay, then you can figure out where the left is going depending on if you're going the opposite or same direction. You can think of the positive and negative as like a reflection in the graph. And we always look at the right side because when you look at the left, it depends on whether you have to go the same or opposite direction. It's harder to think that way when you do the left side, but the right side, it has a direct correlation. The positive goes up, the negative goes down. And then I think of odd as opposite, and then even is the same. So let's go ahead and work one little example of this, or actually two examples. So here is our polynomial. The leading term is x to the third. So we have it's a positive term, so our right will go up. We have an odd exponent, so we will have opposite direction. So between our left and our right side we said is going to go up, so then our left's going to go down because they're going to be opposite of each other. So the leading term is negative 9x to the fourth. We have a negative, or it is negative, so our right will go down. We have an even power, so we'll have the same direction. So with our left and right side, our right is going down, and then our left is going down too because of the same direction. So it's kind of like a logical puzzle. If you figure out your right side, then you can figure out your left. And then if this were negative here, if this one were negative, the right would go down, left would go up. If this were positive, they would both go up. Okay, so let's go ahead and look at the zeros of the polynomial function. And keep in mind, when we find zeros, we are going to actually factor. So we're going to set the polynomial equal to 0. Okay, this is where the graph will intersect or touch the x-axis. So when we set the polynomial equal to 0, we're pretty much saying y equals 0. Then we are going to solve by factoring. Okay, so let's just do some examples of this. So x to the third plus 3x squared minus x minus 3. We're going to factor by grouping. So x squared, that's x plus 3, minus 1, x plus 3. Oh, we technically set it equal to 0. I forgot that step. But my mind, I automatically factor. I mean, it doesn't even have to be set up equal to 0 in order to factor. Okay, so set it up equal to 0. So x has to equal negative 3. And then with this one, x squared minus 1 equals 0. Square root both sides, we get x equals positive and negative square root 1. So we get positive and negative 1. So this is our points, negative 3, 0, negative 1, 0, and 1, 0. So those are our 3 points that we will go on the x-axis. So let's go ahead and talk about how to graph these. We talked about in behavior, we talked about finding our intersections. So graphing. Polynomials. And this goes for the other way, the non-factoring way. So, but in this case, we will determine the in behavior. And we're really going to just sketch these graphs. We're going to find all zeros of the function, or that's the fancy way of saying the x-intercepts. We are going to find the y-intercept, which would mean x equals 0 or just a constant. And if you're finding the zeros of the function and x equals 0, then y will equal 0 as well. And then you graph and find values between these zeros, which we're not going to really work that. We're just going to sketch it. And then we need to know about the zeros and their multiplicities, if I said that right. Sorry if I didn't. So if the zeros do not repeat or repeat an odd number of times, your graph will go through the x-axis. If the zeros, when you're finding the zeros, when you're factoring in this case, if the zeros repeat an even amount or number of times, the graph bounces off the x-axis at those points, okay, or at those repeated zeros. So let's go ahead and graph one of these. or graph several of these. And these are pretty fun, especially when you get to sketch them. When you're doing these accurately, it really isn't all that fun. So, well, it's not fun in the sense of it takes forever. It's tedious. Okay, so for instance, we need to figure out our left and right. So, our right will go up since we are positive, and then our left will go down because we're odd. So odd means opposite. So positive, our right goes up, odd, we go down for our left. Okay, so now we're going to set this up equal to 0. So more or less y equals 0, so what will be our x's? And we get to factor. So since we have 4 terms, we will factor by grouping. So we will get x squared minus 1, x plus 2. So our x's will be negative 2 and positive and negative 1. Okay, because we can factor again and get x plus 1, x minus 1. A lot of students like to just factor until they can't. Or some students just set both of these equal to 0. And when you square root each side of this, do not forget the plus and minus. And I think that's why students tend to factor completely, so they don't have to remember the plus and minus later on. Okay, and then our y-intercept, so if we plug 0 in for all of these, so 0 plus 0 minus 0 minus 2, we'll get a negative 2. So our y-intercept is just the constant here. So then when we graph, I'm going to graph over here so I'm not stretching and going back and forth. Okay, so sketching our graph. And you know what? We'll actually do this. There we go. Okay, so sketching our graph. So our x, at our x, we'll have negative 2. So here's negative 2. And we'll have a negative 1 and a positive 1. And none of these answers repeated. Our y-intercept's at negative 2. Okay, and each of these large tick marks is 1. So then we have our intercepts. Our right is going to go up. And then we are going to connect. Oh, before that, our left is going to go down. So our right's going to go up, our left's going to go down, and then we are going to connect our dots. Okay, and this probably doesn't need to be up so high. I mean, you can plug in negative 1.5 to get to another, it looks like another fraction. So this probably didn't need to be so arced, but we're just sketching the graph. So what we're looking for are the end behaviors, the intersections, or the x-intercepts and the y-intercept, and then the multiplicities. And I'll show you those. So let's sketch another graph. Okay, so our left and our right. So our right is going to go down because we're negative. We have an even exponent, so that's going to go the same. The left is going to go the same direction. So we're going to set this equal to 0. We have a greatest common factor of negative x squared. So we'll get x squared plus, no, not plus, it will be minus 2x plus 1. And then we'll have x minus 1 times x minus 1 after we factor that. So our x equals 0, positive 1, and a positive 1. So I'm going to star this up here saying that we actually had 2 answers of positive 1. If it were 3 negative ones, or if it were 3 of these, I wouldn't start up here because we won't have to bounce off. Since x is 0, since we have x for 0, then y is 0 if we plug 0 in for all of these x's. So let's go ahead and graph these. So we have a 0 on our x, 0 on our y, and then we have a positive 1. Okay, and our right is going to go down and our left is going to go down. So on our 1, we had 2 1s as our answer. So we're going to bounce off here, come back up, and get our 0. And yes, that bounces off as well because we did have 2 of these as well. Okay, we had x squared equals 0. Well, x equals 0 and x equals 0. We actually had 2 answers here. So that's why that one bounced off as well. Because this is our 4 answers. 1, 2, 3, 4. 1, 2, 3, 4. So we actually have 4 answers, but they were repeated. And since they repeated, they bounce off the graph. Okay, one more and then I will end the video. And we'll do an x to the third one this time. So here is our graph. We need to find our left and right value, or the in behavior. So our right is going to go up since we're positive. We're odd, so we're going to go down on our left. So opposite sign, or opposite directions, and then right is positive. 0 equals x to the third plus 2x squared minus 4x minus 8. So we will factor by grouping. So x plus 2, x plus 2, that's good. So we'll have x squared minus 4, x plus 2. I'm going to keep on factoring. Okay, so this one turned into these two, and then I just included the back one. So this means x equals positive 2, and then it also means negative 2, but we had a repeat. So I'm going to put a little star or a mark above my negative 2 because it will bounce off. My y-intercept will be at negative 8. Plug 0 in for x, you will get negative 8. So plug in our values. So we have positive 2 and negative 2, and we'll have negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Our right is going to go up, so our most right point, which is the positive 2, is going to go up, and our most left point is going to go down. Okay, so our negative 2 is going to bounce off, so we're going to touch our negative 2 and bounce back down. We're going to go down to our y-intercept, and there is the sketch of our graph. And actually, if you look at the graph, it actually comes down to here instead of coming back up. It goes through the y-axis and then comes back up. But this will be fine for now because all we're doing is sketching the graph. So we need the end behaviors, the intercepts, their multiplicities if there are any. And I'm sorry I screw up saying that word. And then the y-intercept. So in behaviors, x and y, or x-intercept, y-intercept, and then bouncing off or going through. So that will conclude this video.